So we're going to take notes on evolution. And we've just finished watching some videos about the evolution of things. So I've split your sheet in front of you in half. On one side, with the sheet that you're looking at, if you look at your left side of your paper, this is where we're going to write today. Tomorrow we're going to write on the other side. So I've already folded it. Why don't you go ahead and draw a line? Well, actually, don't draw a line yet. Because along the top, we're going to put a title. Calibrated. Let me just get a marker out here 1 second. All right, so we're going to title it Darwin Theory of Evolution. Right across the entire top. Notice I'm on my tippy toes. I'm so short. Actually, I'm tall. The board is just really high. All right. Now, on my screen, pretend like this is the left side of your paper. So, me looking at it, you're going to put a line down the middle here, and then you're going to write everything here. If we need to go over, you're going to put everything that belongs on this side on the back of that same page. Does that make sense? Yeah. Tomorrow, we are going to put some things on the right side and on the back of the right side. All right? I'm going to tell you what to write on the right side tomorrow. But on the left side, we're going to document who Darwin is and some information about what he had to tell us, okay? So Darwin. His first name is Charles, in case you want to put that there. He is a British naturalist. And he was born in 1809. And the reason why I give you the time, not because you need to remember, but you need to be able to put into a timeline of when these things happened. How long ago was it from now? Okay? Now, in your middle line, right along the fold, I want you to write developed ideas right along the middle, because one idea is going to be on the left, the other idea is going to be on the right. On the left side, where you're looking at your paper, this idea is evolution. So far, so good? All right. On the right side, I'm going to have you write the title, but then this is the last and only thing we're going to write today. On the right side of your paper, go ahead and write natural selection. I'm not going to write it on here because this is just going to be the left side. But on the right side at the top of the page, write natural selection. S-E-L-E-C-T-I-O-N. Natural selection. I'm just going to make my pen a little bit smaller. Okay? Yes. At the top of the right side, yeah, because all that's going to include everything about natural selection. Are we good? All right. So on the left side, we have evolution. Just to refresh our memory, evolution is the gradual development of something. And we noticed that in the videos, correct? It went from simple to what? Complex. Everyone good? All right. So that is what evolution meant. However, for evolution, Darwin believed that individuals or living things, I'm just going to put things, were transformed I'm moving back so you all can see. Into a species that were what? The same? Different? Than their ancestors. For example, reptiles to birds. There's the theory that dinosaurs are more similar to birds than they are to reptiles. Yes?
I have a question. If Darwin later said that his theory is valid, why
We still have to know where this whole evolutionary theory came about. We still have, because that tells us, our past tells us about our future and tells us why certain decisions have been made throughout life, because these were based, even though later on it was something that was disproved, we still need to understand why certain things were explained the way they were because of this theory. Plans were made because at the time that this theory was in place, this is what it was. Now, in the beginning, I told you that these are theories, so I'm not telling you what to believe and what not to believe or disprove or disbelieve what you have been believing, but this also explains the theory of humans evolving from apes. This is where that theory came from, Darwin's theory. So, can I go to another page so that you all can see? Okay, you keep writing on the left side. So, according to Darwin, according millions of species. Millions of species today slowly evolved over billions of years from a common ancestor. Are we all good? Now we're going to be drawing a little chart. And again, like I said, if you don't have space on your front, I want you to start to draw it on the back. But first I'm going to write out what this chart is. So this whole evolution of species over billions of years coming from a common ancestor, this is represented Now, remember when we looked at the evolution of the video game consoles? At the last end, we saw something that looked like a what? Something that looks like a tree. So this is represented by an evolutionary tree. It's also known as, make sure you're all caught up, a phylogeny tree. Or it's called a phylogenetic tree. It also can be called a cladogram. And what this does is it traces the path of evolution. And the relatedness. Of species. And so basically this is the history of lineage. Kind of like when you do a family tree, you go all the way back down. But this would be a history of lineage and its evolution, how things have evolved. And again, these are theories. So some of these trees that you see, like, how is that possible that they may use the way that the hands were made or the way that the feet were developed and things of that nature. So now we're going to actually draw this tree. And you're going to use pencil and some colored pencil to kind of highlight things out. So I'm going to start drawing in black, and then I'm going to use colored pencil or colors to kind of circle things out and highlight and draw things from there. Any questions about that? Yes. You can go to the back page. If you have not set it right on the back page, right on the back of it. One second. Alrighty. So evolutionary trees can look kind of different as they go along, but they represent the same thing. So basically, you'll start off for this one by drawing a V.
You drawing to our filter.
Yes, everything that I draw in black, you draw in black. You take up, like, leave some space along, like, draw it within, like, a middle box of your box. Now, you go over to the back, 'cause this is the last thing we're drawing about evolution theory. So go to the back and go draw your triangle, like, in the middle of your paper. Or I'm not triangle, a V. I'm going to put a Y there. You're also going to go about a little way down and put another Y. Now these shapes here are going to represent the actual organism. So we're just going to, just to make it simple, a star, heart. This one is a circle, triangle, a square, and a diamond. All right, so these are just going to represent, these are just going to represent organisms. because this is representing how the tree goes about. And I'm just trying to run in my mind how I want to lay this out to you so that it's understandable. Now, when reading this tree, it is very important that you understand that this does not read across where it says this happened first and then this happens last. This actually goes from the bottom up, or if it were to be flipped over, it's going to go from the end of the tree where there's nothing, little to nothing, to where there's a lot of things. So you want to go ahead and label this now, and then this is then. Now and then. So it's going up like that. This portion here, I put color pencils there for you. You can write in pencil and then underline in your color pencil, or however you want to do it. But this portion here is considered the root. This would be the common ancestry. These areas here I'm just going to draw a line out with green. These would be considered the nodes. This identifies common ancestry amongst the species. So this is like diversification of the species. So I'm going to put diversification among species. And you can put on your paper as well, this common ancestors among individual species. This is among, the root is among them all. The nodes is among specific species. So for instance, when we look here, the I don't know my shapes. The heart and the circle have a common ancestry that are different than the common ancestry between the star and the heart, or the circle and the triangle. Does that make sense? So see how they connect together. That shows their common ancestry. Okay? Any questions so far? All right. Everyone up to date? All right. These here are considered the tips. So these are our current organisms. And they're considered our terminal nodes. These lines, and I'm only going to represent one. This is considered a branch. That's why it's a tree. These are our branches, all of those. And I'm only going to identify one, but every one of those lines are considered branches. And we all know what a branch does. It links things together. Okay? Are we so far so good? Okay. Now, when we have the connection with the smaller bees, this is considered the sister taxa. What does the word taxa mean? Remember, where does that come from? Where did you hear that from? No. In your previous notes, we talked about classification of organisms. Taxonomy. What is that? Based off their characteristics. That means they come from the same species. So they have a direct ancestry. How do I word it? This should say same direct ancestry. Now, just because I just highlighted this one here does not mean that this is not a sister taxa. That is too. They look like that. And this is just a simple one. As you can see in the video game console, it gets really complex. All right? Any questions here? Okay. Now, even though we label these, put arrows here in the same color that you circled it. Only because this is also considered, when we look at it as a group, it's considered something else. So then circle the whole thing in another color. I'm going to circle mine in red. I want you to circle yours in another color. All right. So, although we circled them in purple because we're categorizing as the tips, circle them in another color, and then we're going to write what this is for. So in a group, this is called an in-group. And this shows common characteristics. This shows common characteristics relative to this tree. Because there are going to be other trees out there, like the one that has to do with plants. This one maybe one has to do with mammals or other types of organisms, invertebrates. This can branch out. So when they're all grouped like this one group is going to be the in group and it's going to show common characteristics relative to this tree. Does that make sense? Okay. And then lastly, okay, so we've identified these lines to be branches, but if you notice this last one here, you see this? This one is not connected. It doesn't really have a commonality with all of the other ones except for the root. So any one of them that looks like this, and this is why we color code it, because you can see this gets kind of tricky, but this will be considered the outgroup. It has a common main ancestry. These are organisms in the phylogeny but does not fit specific classification. They're related to the root, but there's no common characteristic amongst them all. So you might want to add that, related to the root, but no common characteristic amongst them all. And then that continues our notes. We're going to talk about the natural selection tomorrow.